Hello, welcome back. Today I will solve LeetCode 673, number of longest increasing subsequence. In a previous video, I have discussed the approach to find the longest increasing subsequence of an array. If you have not watched that video, I have the link to that video in the description below. I would suggest solving that problem first before attempting this one. In this question, we are tasked to find the number of the longest increasing subsequence given an integer array. For example, in this array, the longest increasing subsequence are 13579 or 13479. So we will return 2 as the total number of the longest increasing subsequence. Suppose we are given this array where all the values are 2. The longest increasing subsequence is 2. And there are 5 of them, so we will return 5. Now that we understand what is required of us, let's start building the solution. Again, we will use dynamic programming approach, and in this case, we will make 2 arrays. One is the DP array in which we will store the maximum length of the longest increasing subsequence, and the other array is count, where we will store the number of longest increasing subsequence we have found. Again, we will build up the solution. What are these states if the array has only one element, 2 elements, 3 elements, etc. Now let's start with the first element. So suppose the array only has the first element. The longest increasing subsequence here is 1, and there's only one of them. If the array has these 2 elements, then the longest increasing subsequence is 1, 3. And there's only one longest increasing subsequence. Here, if the array has 3 elements, the longest one is 135 with a length of 3, and again, we only have one of these. If the array has these elements, the longest one we can make that includes 4 is 134. There is only one longest increasing subsequence. Okay, at this position, the longest increasing subsequence, including 7, are 1357 or 1347. The length of the longest increasing subsequence is 4, and there are 2 such sequences with the same length. And finally, for the whole array, we have 2 longest increasing subsequence of length 5. Okay, so let's build up the pseudocode. To start off, let's scaffold the pseudocode with the code that we have established for finding the longest increasing subsequence from the last video. Again, we have the double for loop, and in the inner for loop, we will test whether num of j is less than num of I, and if that's the case, we can make another increasing subsequence. As mentioned last time, at any iteration when we populate dp sub I, if we find a new increasing subsequence, the current dp sub I is dp sub j plus 1. In the inner for loop, it is possible that we will find increasing subsequence of different length. And each time when we find a new increasing subsequence, then we have to ask, how does that compare to the existing one? So if the current length is less than the dp sub I, that means we have a shorter increasing subsequence, and in this case, we don't really care. Alternatively, the current length is the same size as the one that we have seen before, and in which case, we'll update the count of I with the count of j. Okay, let's take a look at the example for this scenario. Suppose we are at this iteration where we find that we can make an increasing subsequence ending with 5 and 7. And then we know that that subsequence has a length of 4. So we update that in the count array, having found one sequence of this length. Now, in the next iteration involving 4, we find that 4 and 7 can also be a part of an increasing subsequence that has a length of 4. In this case, we will update the count array, and we will add the value of count here to the number here. And so this number becomes 2. The third scenario when we find an increasing subsequence is that we've defined a longer increasing subsequence. So that is the else clause here, where the current dp sub I is greater than dp sub I. In this case, we will just update the dp sub I to the current dp sub I, and we'll update count sub I to be count sub j. And let's take a look at an example of this scenario. Suppose we are at this iteration and we find that 4 and 9 can be a part of an increasing subsequence that has a length of 4. Now, if we move to the next iteration involving 7, we find that 7 and 9 can also be an increasing subsequence, and that has a length of 5. In this case, we'll take the counts here, we'll update the count sub I with this value. It's very straightforward. Now let's convert this pseudocode to real code. This C# implementation is provided in the GitHub links below. I start with initiating a DP array and also the count array. Both of them would have the same size as the nums array. Now I will do an array field of the two arrays and populate them with the value 1 because that is the default value. And then I will introduce the nested double for loop and also add the logic we just mentioned in the pseudocode. Once the double set of for loops are done, the DP array and the count array should have these values. Next, I will find the longest increasing subsequence, and in this case, is the length of 5. I will iterate the DP array, and I will find all the DP sub I that equals to 5, the maximum value, and I will take the counts of the corresponding index and add that to the total. In this case, there's only one instance where DP sub I equals to 5, so the total will be 2. Okay, so let's take a look to see if this works. And it's good. We are done. If you have any questions, please leave a comment below. I will see you next time.